A confirmation about the audio, please, guys. If the audio is clear and available, kindly confirm. Thank you. So, hello, a very warm good evening to all of you, and welcome to Baiju's Exam Prep IAS. Welcome to the session of climatology, where yesterday we had basically discussed the concepts about certain types of inversion, that is the frontal inversion as well as the valley inversion. After that, we started discussing about what is air pressure. And there we saw that air pressure is basically the total weight or pressure induced by the air column on the ground surface. So any region, whatever is the total weight imposed on the ground surface by the air particles, water vapor, etc., that is regarded as the air pressure. Now, we saw the various factors based upon which the air pressure in a region can vary. We have seen that low pressure or high pressure, low pressure basically is lower than in comparison. It is always on a comparative scale. So, for example, even though the pressure normally at the sea level, the average pressure at sea level is how much? Do we remember that? What is the average pressure at sea level? Very good. Beautiful. How can pressure be zero, my dear friend? It is 1013.2 millibar. That is the average pressure. Now, in comparison to that, a region having lower pressure than that will be regarded as a low pressure area. A region having a greater pressure than that will be regarded as a high pressure region. Now, beyond that, we carried the discussion further, and basically we observed the fact that when we talk about this atmospheric pressure, there is a significant influence of temperature. And that is because any region which is very warm, that region being very warm will have a greater movement of particles. Any region which is very warm will warm up the air above as well. So greater movement of particles, many of the particles will escape the system. So the air becomes lighter, and lighter air will always tend to rise up. It will rise up till mostly the level of tropopause. So whenever the air is rising, it will have a low pressure. In a region where the air is sinking, it will exert that pressure, it will induce that pressure, it will create a condition of high pressure, right? So that is basically the case of high pressure and low pressure induced because of temperature. We have seen that temperature is not the only factor controlling pressure. For example, if any particular region witnesses the movement of winds from opposite directions, and these winds, when they converge and they rise up on the ground surface, you will always witness a kind of a low pressure. So, convergence of winds, eventual rise up of the winds, creates that low pressure condition on the ground. Contrary to that, if let's suppose you have convergence in the upper atmosphere, that is in the upper portion of troposphere, if the winds they come, they converge, and then they start sinking down, that is when, as these winds will sink down, they will exert the weight on the ground surface, leading to a high pressure. So sinking air column, regardless of the temperature condition, can have a high pressure. Rising air column, regardless of the temperature conditions, can have a low pressure. So these are dynamic pressures. Now we observe the movement of wind. Winds always blow from a high to a low. So from a region of a high pressure where you have excess of air particles to a region of low pressure where you have a deficiency of air particles, there will be that consistent movement of winds which shall be observed. So here, when we talk about these movement of winds, these movement of particles, always it is going to happen from a high pressure to low pressure. But the direction, the speed, the velocity of the wind in itself, that is dependent on various controlling factors such as the pressure gradient force. That is the difference between the low and a high pressure. That is the pressure gradient force. then greater the pressure gradient force or greater the difference between high pressure and low pressure, more will be the movement of the winds. Coriolis force, due to which winds moving in the northern hemisphere bend to the right and winds moving in the southern hemisphere, they tend to bend to the left. It is completely induced only because of the rotation of planet Earth. Then the frictional force, which reduces the speed of the wind as the wind basically moves closer to the ground surface. So that is the reason why the surface winds, they are slower in comparison to the upper atmosphere winds, and also as compared to the winds moving over the sea surfaces. The winds moving over the sea surfaces, they are extraordinarily quick, very, very fast. So these are few of the factors that we looked into. Then we started looking into the unicellular model. The unicellular model of atmospheric circulation, which was propounded, that only talked about the thermal conditions. That because of heating around the region of equator, there will be rise of air. In the region of the poles, very cold conditions, sinking of air, and you will have a circulation from equator to poles. But later on, William Ferrel basically made this observation that you cannot have a wind which is so strong enough that it can originate from the region of poles and reach the region of equator. Frictional force will take care of it a lot earlier than that itself. And moreover, the factor that there is a Coriolis force, the winds will bend so much, they will never be able to reach the region of equator, or even in the upper atmosphere, winds from equator will never be able to reach the region of the poles because they will be bending quite significantly to the right portion. So that is why unicellular model was basically discarded. From that came the genesis of the most acceptable and accepted model of atmospheric circulation, that is basically the tricellular model of circulation. Tricellular model of circulation. So this tricellular model of circulation, what is this? So let us understand that. So here, basically, let's consider. So we will be depicting the case of northern hemisphere, and the same thing will be observed even in the southern hemisphere. So it is a replication of it. So don't worry about it that you are only talking about northern hemisphere. It is simply going to be a replication or a repetition. So here, when we talk about the tricellular model, so basically we consider different places: 0 degree, 30 degree, 60 degree, and 90 degree north. Okay. Now here, please don't get confused that why only 30 degree, why not 29 degree, why not 31 degree. So let me make it very categorically clear. Please listen to this very carefully. I will get the questions from this. I know you will ask question from this. So the person who is going to ask the question at that point of time, I will be extra kind to that person at that point of time. So please listen to it very carefully. We take 30 degree as an average. Here, whatever might be the condition of a pressure or a circulation, 30 degree, it is not fixed. It can be 25 degree. It can be in certain seasons 35 degree. It can be 34 degree. It can be 24 degrees, somewhere in that range. So on an average, we consider 30 degrees. Similarly, on an average, we are considering the position of 60 degree and even equator. 90 degrees is where it is always going to be fixed. What am I trying to say? Let us try to understand here. So, first of all, the region of equator around 0 degree, that is the region which will get significantly heated up. So, because of heat, the air will rise up. The air will get very warm, and this air will start to rise up. And please be very careful and sincere for the next 20 minutes, guys. That is all the attention span that I am seeking. 20 minutes, pay utmost attention here, apply the logic that we have studied till now. Trust me, if this portion is clear, regardless of the fact that you might have confusion in the later portions, but if this portion is clear, you will automatically be able to solve multiple different types of questions and queries which arise basically because of this circulation. If you understand this circulation, jet streams will be easier. Walker circulation, Enzo cycles, El Nino, La Nina, that will be easier. Indian monsoon will be easier. Everything becomes very, very easy. Global climatic distribution becomes very easy if you understand this. So let us try to put maximum focus. And here, for a brief moment, what I will do is, because here we have a kind of a blank slide available, or should we take it here only? Here, in this particular image, we will be depicting the movement of air in the upper atmosphere. Okay, here we will be depicting the movement in upper troposphere. Upper tropospheric movement. So here, as this air rises up, it will rise up till where? Up till which portion will it rise up? Till the region of tropopause. In the stratosphere, it won't rise. We have discussed it in significant detail why the air won't rise into a stratosphere. So here it will rise up till the region of tropopause. Now what will happen? After it hits the tropopause, what happens? Will the air puncture the tropopause? Will the air start falling down? We have studied yesterday. What happens? Very good. It gets diverged. There is a divergence. Right? Here, there will be a divergence. One will go towards the northern hemisphere, other will go towards the southern hemisphere. So let us study this movement of wind. This particular movement of wind, let us study with the help of this image. So here, from the region of around 0°, the air has risen up, and now we are only going to depict the upper air movement. Now in upper air, will there be a Coriolis force in action? What does the logic tell you? Will there be a Coriolis force in action? Beautiful, guys. Very nice. Yes, there will be Coriolis force. In fact, the speed of winds will be more, and we have seen in the case of Coriolis force, faster movement of winds means more deflection. So here, there will be a significant deflection of the wind. Wind rising from equator will bend to the right in the northern hemisphere. Now, in this case, if I ask you to apply your simple logic, no application of geography here, just apply your simple logic. With this level of deflection and deviation, can these winds reach the region of the poles? Can these winds reach the region of the poles? Very good. All of you have given the correct answer except one. So it won't be able to reach the region of the poles because there is so much amount of deflection. It won't move any further. It will start accumulating furthermore in these areas. It will start accumulating in these regions. Right. Now here the winds have started accumulating. So what is the problem? Let the winds accumulate there. But meanwhile, there is further heating of the region around 0°. More winds will rise up. As more winds will rise up, these will eventually hit the tropopause. They will diverge. So more winds are getting supplied here. There is an abundance of wind. And by the way, the air at this region the top of tropopause? Will its temperature be low or will it be a warm air? What do you think? It will be very cold. Very cold, because at the top of troposphere, we are talking about a temperature in the range of around -60, -40, -50 degrees Celsius. So it will be very cold. Plus, there is overall dominance and more accumulation of the winds in that area. So what will that lead to? Eventually, the winds will be forced to sink. There is quite a significant abundance, so they will sink. They are sinking not because of the temperature near the ground surface, by the way. They are sinking purely because of the conditions prevalent above, right? So they will sink. Now, as these winds have sunk, they will hit the ground surface. Then what will happen? Will these winds penetrate the ground? Will it hit the ground and reflect back? No, they will diverge. Very good. So here they will diverge. Now, on the ground surface around 30 degrees, will there be a low pressure or a high pressure on the ground surface at 30 degrees? Beautiful. Very good. There will be a high pressure. Why? Because you have sinking winds, sinking air column. There will be high pressure. So one part of this wind will go towards the region of equator to fulfill the vacancy created by the rising air. Because rising air creates that vacancy. We have discussed that yesterday. And that is where you will have one part of this wind moving towards the region of equator. The other part. So here, in this region between equator and 30 degrees, you have a complete circulation. If you would observe that rise of air from the region of equator moving in the upper troposphere and then sinking, creating the high pressure on the ground, and again, the feedback of the winds towards the region of equator. So you have a complete circulation attained. Now, for a brief moment, let us take a look at the region of the poles. Now, the polar area. Polar region will always be very cold, regardless of the season, the which part of the year, which year are we talking about? Polar area will always be very cold. It will be amongst the coldest regions across the planet. Now, in these polar areas, if you observe sinking air, so what will it do to the ground surface? Here, why there will be sinking air? First of all, because of very cold conditions. Very cold conditions, they are generally associated with a high pressure. So here, these winds will then move southwards from the region of the poles. They will move southwards. Now here, they are coming southwards. Here there is another wind movement which is coming from here, from the region of tropics. These winds, they will converge. They will collide. And when they will collide, regardless of the temperature near the ground surface, when the winds will collide, they will converge. What will happen? Very good. They will always rise up. So here, there is going to be a rise in the wind motion. They will rise up till which level? Up till the level of tropopause. So they rise up, then they will diverge. One portion goes towards the region of the poles. Another portion goes towards the region of the tropics. And you have a complete circulation. Now, I will come to the nitty-gritties and the details of this circulation. I will repeat this entire circulation once more, so don't worry about it. Before that, let us get some basics clear. At the region of 0 degree, at the region of equator, Will this be a thermal low pressure or will this be a dynamic low pressure? I hope everybody is convinced that it is a region of low pressure. Will this be a thermal low pressure? Will this be a dynamic low pressure? Very good. It will be at the region of 0 degree, it will be a thermal low pressure. Why will there be a thermal low pressure? Because this low pressure has been created purely by virtue of heating. So this is what is also known as equatorial low. Equatorial low. Created because of heating. So this is a thermal low pressure. Now, at 30 degree north, will that be a thermal high pressure here or will this be a dynamic high pressure in this region? Everybody can agree here? It is going to be a dynamic high pressure because this high pressure is because at 30 degrees generally you experience higher temperature, right? Warmer conditions, but still you have a high pressure here purely by virtue of the sinking air column, right? So here you have a dynamic high pressure. This is known as subtropical high. Then you have the region of 60 degrees. Now here, basically, is this going to be a thermal low pressure? Is it going to be a dynamic low pressure? What do you think? Beautiful. Very nice. Looking at this, I don't think I need to repeat the entire thing again anymore. Good. So this is going to be a dynamic low pressure. Why? Because here the low pressure is not, what is a thermal and a dynamic? Thermal means influence of temperature has created a low pressure. Dynamic means just the movement of winds have created that low or high pressure. So here the low pressure is not created because the land has been heated up. Here the low pressure has been created because the winds are converging and rising up. So this is where you will have a dynamic low pressure. This is known as subpolar lows. Low pressure. And then you have the region of 90 degree. 90 degree. Here, is it going to be a thermal high pressure or a dynamic high pressure? Very good. Okay. No, not very good anymore. Okay, all those who are saying thermal, why is it going to be thermal at 90 degrees? And all those who are saying dynamic, why will it be both? No, both is not there. At one place, either a pressure is created due to thermal condition or dynamic condition. Those of you who are saying dynamic, why dynamic? Yes, correct. Poles around equator means, what is the meaning of this poles around equator? Thermal due to low temperature sinking, there is no heating source. Okay. C, warm and cold air collision. Mohammed, at 90 degree, where is the warm air coming from, my dear friend? Or is the air colliding from anything? So, thermal, by thermal, please don't, I understand that most of the images that you see in the case of thermal, you observe heating only. Thermal means influence of temperature. So very cold conditions, when they create high pressure, that is also influence of temperature. There the high pressure is created. Why? Always go to the reason of why. Why is the high pressure created? Because of very cold conditions. So this is also a thermal high pressure. That is what is known as polar high. So let me repeat this entire circulation once more. So basically what happens, around the region of equator, the air gets heated up quite significantly because the region around equator, that gets warmed up. And listen to this carefully, because here we are, after this I'm going to ask a couple of questions. So here, at the region of equator, around the region of equator, there is significant amount of heating which is observed. So the heating of land will warm up the air above it. So the air above it, after it has gotten warmed up, will start to rise. As the air begins to rise on the surface, there will be low pressure. But this low pressure has been created. Why? Because of the heating of land. So it is a thermal low pressure. Now, as the air is rising up, it will hit the tropopause. It will diverge. One part moves in the southern hemisphere, another part moves into the northern hemisphere. Now, as this moves, it influences or is impacted by the bend of the Coriolis effect. So the winds, rather than moving straight like this, they won't be moving like this. The winds, rather, they will be moving, they will be bending to the right. As they bend to the right, you will observe an accumulation of the winds roughly around 30 degrees north. Because they have risen at 0 degrees, so it takes that much distance for the deviation and the accumulation. Now, these winds keep on getting accumulated. Meanwhile, more winds are rising, more warm air is rising from the region of equator. So there is further, let's suppose the winds are rising here, they have gone like this. Now they have started accumulating, more winds are rising up, more is getting pushed. So eventually, this wind will get pushed down and it will start to sink. When it starts to sink, it will hit the ground surface. And when it hits the ground surface, that is when, on the ground surface, around 30 degrees, it will create a high pressure. Because if this is the region of 30 degrees, you have sinking air. That sinking air has created that high pressure. So whatever might be the temperature at 30 degrees, the air has not sunk because of the temperature at 30 degrees. The air has sunk purely because there's a convergence in the upper atmosphere. The winds have no place to go. There's accumulation. The winds are pushed down. They are eventually forced to the ground. So there is a dynamic high pressure at 30 degrees, which is the subtropical high pressure belt. Now, after the winds they hit the ground, then they will be diverging. One part goes simply to fulfill the vacancy created around equator because of the rising air. Another part starts traveling to the region of the poles, northward movement. But in the meanwhile, when we consider the polar areas, they exhibit very low temperature. Polar areas, they indicate a very low temperature. So due to, by virtue of very low temperature, you generally have a sinking air. We have seen earlier also, yesterday when we were taking a look at the detailed look at the air circulation, we observed that in the polar area, there is a significant, or colder area, you will have sinking air, warmer area, you will have rising air. So you have a circulation. Now in the polar region, the temperature is always so very low that you will have a sinking air column. So their sinking air column around the region of the poles will always create that high pressure. Always. Now, think about it. Here the air is sinking. So on the ground, it has created the high pressure. Now, after that, where will the air go? It will move southwards. In all direction, it will move southwards. Right? Experiencing the Coriolis force, it will move southwards. As it moves southwards, around the region of 60 degrees, it basically converges with the warm tropical winds coming from 30 degrees. From the subtropical high pressure, the winds coming from the 30 degrees, they join, they converge the polar winds. And when the winds, they converge, will they start intermingling and having a good time altogether? No. When the winds converge, they eventually rise up. So regardless of the temperature around 60 degree, you will have a rising column of air. And that rising column of air means low pressure on the ground. So that is why on the ground surface, you have the condition of low pressure. So that is basically how this entire circulation is observed. Okay? Because polar air from the region of the poles, can it go northwards? Can you think about the polar air going northwards? Where will it go? Garima, why southward movement? Can you think about the movement from North Pole? Where northwards will the air go? Let me know. If this is the polar region, this is the polar region, any direction that you move, it will be the southward movement. If we talk about the South Pole, any movement that you make, it will be the northward movement. Isn't it? Is that understood? Now I understand. Okay. So you had a thought that north to the poles also there must be some land to the north of the poles. Okay. So this is the kind of a circulation. Here you will observe three cells of circulation being formed in each hemisphere. That is why this is known as the tricellular model of atmospheric circulation. This is what is known as the polar cell. This is known as the Hadley cell. And this is known as the Ferrel cell. After William Ferrel. Now, here, if I say a statement, let me know if it is true or false. Hadley cell and polar cell, they are created by the thermal pressure zones, and Ferrel cell is the dynamic pressure cell created in between. True or false? Very good. All of you are correct. Repeat. Meanwhile, GIB, yesterday also you had asked the same thing. After I had asked the question, everybody had given the answer. And then you asked, what is the question? Okay. Meanwhile, Shelja has a different question. Can wind overlap? No. So it is going to be true. All of you have given the correct answer. Very happy to see that. Other than a couple of you. So the Hadley cell, its main driving force is the low pressure created due to the heating. If that low pressure has not been created, the winds will never rise up. If the winds will never rise up, they will never diverge in the region of tropopause. There will never be a sinking of air furthermore. So Hadley cell is driven by thermal conditions. Polar cell, the movement of the wind is initiated because of the cold winds or the cold conditions hitting the ground surface. So that is also thermal. So you have two circulations. In between them, just like a gear mesh arrangement, you have the dynamic Ferrel cell, where the dynamic low and high pressure get activated. Okay? Now, see, I told you guys, I will get a question. Why does the air from equator settle near the 30-degree latitude? Okay. So, basically, I had told you in the initial classes, its initial portion itself, that it is not always going to be the 30-degree. It can be 25-degree, it can be 35-degree, it can be 29-degree. Why the air will sink? The air in the upper tropopause, when it goes eventually to the northward direction, it will get deviated to the right. It will start bending to the right. As it starts bending to the right, there will be an accumulation of air near the region of 30 degrees. More air, as it gets pushed towards them, they will be forced to sink down because they cannot move any further north. Because of the bending, they cannot move any further north. So they keep on accumulating. Eventually, they will sink. Okay, right? Is it the same process for all layer? No, it is the process only for troposphere. Can we say Hadley cell equal to subpolar cell? No, not correct to mention that. Ankush, at 60 degrees subpolar region, how much pressure is created by collision? Only that too heavy, cool air column rises. How much at 60 degrees, how much pressure is created? Low pressure is created there. Low pressure is created because the winds, they will converge, they will be forced to rise up. It is a low pressure which will get created. Okay. Will all the cells be always formed at equidistant latitudes? No. I will show you also what is the modern concept and what is the reality which happens on the ground surface. I will show you that also. Lakshmi, this is the upper tropospheric movement of the winds in the region around troposphere, top of troposphere. So that is where I am indicating that the winds basically, when they will rise up from the region of equator, the winds will start moving northwards. But because of the influence of Coriolis force, the winds will be deviating to the right. So around the region of 30 degrees, they will accumulate and then eventually they will fall. Why size of cells? Why size is reduced of cells? Because the height of troposphere is not fixed. The height of troposphere is maximum around the region of equator. It is very low around the region of the poles. Okay. How question is arises from this concept? I will tell you about the question which can be framed and which has been asked from this topic. I'll tell you. Don't you think equatorial low is thermal as well as dynamic? No. Equatorial low is purely thermal. Akash, remember the discussion that we had about the frontal inversion, the formation of a front? Do you remember that? Where we said that hot and cold air, they don't get mixed, right? Why is it called as Hadley and Ferrell cell? Hadley and Ferrell, after the individuals, obviously. Okay. Can the winds be deviated again? What deviation? Okay. Let us develop on this concept. As long as we dwell on the same thing, you will overthink. And meanwhile, I will get questions like what are doldrums, etc. Now, here we basically observe that there is a circulation happening across. Now, if I ask you a basic question, around the region of equatorial low, the low pressure is created due to heating. Can that be the case that in every season, it is only the equator which will be the hottest portion? Can you imagine a scenario where only equator will always be the hottest portion? Because eventually it is a thermal low pressure, right? Thermal low pressure is created due to the heating of the ground surface. So, what do you think? Will equator be the hottest portion? Always. The answer is no. For example, during the months of summer condition, I hope we are aware about the location of India. I hope we are aware of that. I sincerely hope I don't need to tell you about the location of the country. So, all the patriotic fellows that we have here, yes? No, right. So, basically, Let's suppose we have a rough map of India. Let's suppose. Now, this is the region of equator. Equator. This is water body. This is the Indian Ocean here. Now, this is the region of Thar Desert here, isn't it? Now, if I ask you a question that during the month of summer, imagine the hottest of the summer, which will be warmer? This portion will be warmer, or Indian Ocean at equator will be warmer? The Thar Desert will be warmer, or Indian Ocean at equator will be warmer? Which will be warmer? Very good. Okay, even if you have a confusion in that, let me know. When we talk about the heating of land and ocean during the summer condition, which gets hotter, land or water? Now everybody knows. So, a very interesting trend I have found out. Repeat the question. No, I'm not going to repeat the question. Thank you. So, very interesting trend I have found out. If I ask you an applied question, you are all panicky and fidgety. You give all random sort of answers. If I take the wordings of the PPT, which has been discussed previously, and then frame a question, everybody is comfortable. So that is very worrying, my dear friends, because if we are we are not able to apply that heating of land and water. So that is where application. So then the global climate is something that you can completely forget out of equation. Please try to have that application. Right. As soon as I said land and water, everybody recalled that yes, we had discussed land gets hotter during the day, land is hotter during summer, land is hotter. But when I said Thar Desert and Indian Ocean, I had many of you talking about how Indian Ocean is going to be warmer. So please don't get confused. What I'm trying to get at here is every particular single question is driven from the basics that we have studied, the basic concepts that we have studied till now. That is going to drive the entire discussion for climatology. So please be very confident, repeat that multiple times. So here, coming back to it, basically, you will observe that around the region of Thar Desert, there will be a higher temperature as compared to Indian Ocean. So, a thermal low pressure most suitably will be created here where the temperature is low, where the temperature is very high. That is where a thermal low pressure will be created. So, in this case, what we see is that the equatorial low basically is traveling away from equator. So, this equatorial low that can shift depending upon which is the hottest portion nearby. By the way, in this region of equatorial low, you have winds coming from the tropics, 30-degree north and also 30-degree south. Right? The winds coming from both 30-degree north and 30-degree south. So we can say that this is a zone for the convergence of tropical winds, because around the region of equator you will have from the northern tropics the winds which come, from the southern tropics the winds which will come. So this zone is also what is referred to as the intertropical convergence zone, ITCZ. Intertropical convergence zone, or ITCZ. It is not a dynamic pressure, it is a thermal low pressure. I will repeat it endless number of times. This is a thermal low pressure which gets created. Okay. Now, this ITCZ can move. Let's suppose This ITCZ, rather than the equator, moves somewhere in the region of 25, 26 degrees. Let's assume the ITCZ is around 26 degrees. Then the air will rise up from here. The air will rise up from here. So if the air is rising from 25, 26 degrees, will it ever sink at 30 degrees? No, it will sink somewhere at 40, 45 degrees. Right. So if it is sinking at 40, 45 degrees, the subpolar low will also shift. So during the northern summers, you will observe that this ITCZ, it shifts north. Wherever there is the land mass which gets more heated than the nearby water body, it will shift to the north. Accompanying pressure zones will also shift slightly to the north during the northern summers. During the southern summers, the ITCZ will shift to the south. So that means the entire Hadley cell will shift to the south. That means the entire Ferrel cell will slightly shift to the south. So shifting of pressure belts. During northern summers, all of them shift north. During southern summers, all of them shift south. Okay. If winds are converging, then how thermal? See here, in this case, GIB, understand the winds, it is not as if the winds are converging, that is why low pressure is created. GIB, let me know. Why is there a low pressure created at the region around equator? Are we aware of that? Why is there a low pressure created? You tell me the answer of this. Because of heating. So if because of heating the low pressure is created, how can it be a dynamic pressure? Now a low pressure region will attract winds from all directions. Always winds will blow from a high to a low. So wherever you have a low pressure, winds will get attracted from all directions, right? Sinking of air? No, Mega. That is absolutely wrong. Anjan, tilted axis of Earth affects the shifting. Tilted axis of Earth influences the various seasons. So the occurrence of seasons is because of the tilted axis. We have discussed in the first class. Now these seasons will lead to shifting. So in a indirect manner, you can say yes. If onshore wind carries moisture content with them, then how Atacama Desert is dry? Because there the wind movement is slightly different. I'll let you know. Now, Twisha, so equatorial low is at south these months? Yes. Will the polar cell shift? Dikshit, no. See, the polar high pressure will always be remaining at the region of the poles itself. So they don't exhibit much of a shift. Okay. Now, here, from this image, what can we say about the surface movement of the winds? We can basically say that on the surface, wind movement is from 30 degrees to 0 degree, from 30 degree to 60 degree, and from 90 degree to 60 degree. These are the three different types of wind movement, isn't it? Now here, this is basically the image of the entirety of the circulation. Now here, let us devise that surface movement. So What is the surface movement? On the surface, from 30 degree to 0 degree, from, let's assume this is your region of equator. Let's assume this is your 30 degrees. Let's assume this is your 60 degrees. And this is the 90 degree. Here also, let's assume 30 degrees to the south, 60 degree to the south, and 90 degree. Now we do know, or should we take a larger image here? Let's take a larger image. Let's assume this is your equator, 30 degrees. (60°), 90 degrees, 30 degrees, 60°, 90°. Now, on the surface, the wind movement is from 30 to 0. So, from 30 to 0, this will be the wind movement on the surface, right? The wind will try to move like this, but there will be Coriolis force. So, they will bend to the right here. So, here, they will bend to the right. Same in the southern hemisphere from 30 degree to 0 degree, because it is the ITCZ, the intertropical convergence zone. So here also they will bend to the left because of the Coriolis effect. Here they will bend to the left. Now, on the surface, we have a wind movement from 30 degree to 60 degree, right? 30 degree to 60 degree. But this will be bending to the right in the northern hemisphere. As you move towards the region of the poles, the bending will also be higher. So these will be bending to the right. Now, winds are generally named based upon either the region or the direction from which they originate. That is the major influencing factor in the naming of the winds. Okay. Again, in the southern hemisphere also, 30 degree to 60 degree, the winds will blow. So here also, you will observe the winds will blow like this. They are bending to the left in the southern hemisphere. Then, in the polar area, from the poles to 60 degrees, the winds will come. In the northern hemisphere, they will bend to the right. And in the southern hemisphere, they will bend to the left. So these are the wind systems which are prevalent across the entirety of the planet throughout the year, right? Throughout the year, they are prevalent. So that is basically where you will have these wind systems being referred to as the permanent wind system or the planetary wind system, because they are present throughout the planet, they are present throughout the year. So these are your surface winds. Again, if I take you back to the same image, from 30 degree to 0 degree, you had a wind movement on the surface which was happening. From 30 degree to 0 degree, observe 30 degree to 0 degree, 30 degree to 0 degree. Then From 30 degree to 60 degree, you had a wind movement which was happening. So from 30 degree to 60 degree, from 30 degree to 60 degree, right? Then after that, from 90 degree to 60 degree, also the wind movement was happening. 90 degree to 60 degree, 90 degree to 60 degree. Now, these are generally named after the direction of their origin or any other name that is associated. So these winds, they are known as, these winds in the tropics, they are known as trade winds. In the northern trade winds, because earlier the merchants, the mariners, the traders would take the help of these winds in order to navigate and reach various different places. That is why the name persisted and it is named as the trade winds. In the northern hemisphere, they are also known as the northeastern trades because the direction is from northeast to southwest. So they are also known as eastern trade. In the southern hemisphere, they will be named as southeastern trade. Okay. Now, here, basically, these winds and these ones, they appear to be coming from the region of west to east. From the region of west to the region of east. That is why these are also what are known as westerlies. It is these westerlies which are particularly strong in the southern hemisphere because of the dominance of oceans. And that is why the westerlies in the southern hemisphere are known by the name of the furious 40s, the fiery 50s, the shrieking 60s, because the westerlies in the southern hemisphere, they are very, very strong because of the overall dominance of the water body. Because over the water body, the force of friction is less. Now, then after that, around the region of 90 degrees, you have the winds which appear to come from east to the direction of west. So both of these, here also and this one also, they are known by the name of polar easterlies. They are known by the name of polar easterlies. Now, these particular winds, they are being driven. Why? What is the factor? The pressure created on the ground. The winds are simply moving from high pressure to low pressure areas. That's it. So you have various different pressure zones created on the ground which drives these winds. So this is your ITCZ or the equatorial low. ITCZ or equatorial low. Then after that, this is what is your subtropical high pressure belt. High pressure belt. Same in the northern hemisphere also. This is your subpolar low pressure. Polar low pressure. And these are your polar highs. Polar highs. These are the various pressure zones created. Okay, for everyone, this is another case, another question. And Ankit, you should be proud of yourself. Why we choose 30 and 60 only? Why not other latitudes like 23 and 66? Okay. See, I know the nature of the questions beforehand. That is why it is not a kind of a praise I am giving, Ankit, that you are thanking me. It is a kind of a sarcasm. Please understand the sarcasm. Because why I'm telling you this is because I have discussed it separately earlier itself. I That is why I ask, please pay attention in the session. I had told you that this is the question that you will have, this is the answer for it, but still you have the same question nonetheless. Fair enough. So what do you do in that case? Basically, it is not the case that only 30-degree or 60-degree will only witness these kind of wind movements. It can be 25-degree, it can be 35-degree, it can be 29-degree, it can be 31-degree, it can be 26-degree, it can be 33-degree, 34-degree. We take on an average to be 30 degrees. Similarly, in the case of 60-degree, it is not exactly at 60-degree where it will happen. It can happen at 55-degree, it can happen at 65-degree, it can happen at 58-degree, it can happen at 63-degree. On an average, we take 60-degree. It is not always that ITCZ will be formed at 0-degree. It can be formed at 20-degree north. It can be formed at 9-degree south. It can be formed at 10-degree south. On an average, we consider it to be the 0-degree. Is that understood? Is that understood now? Okay. Pihu, I have read in my book that winds are named from where they originate, but the names of westerlies and polar easterlies are not according to them. So then the name of trade winds is also not according to them. Then the name of Lu is also not according to them. The name of Chinook, Fohn, Mistral, Sirocco, Harmattan, none of them is based the name according to that. So what do you think? Are all the winds named incorrectly, or is there some issue in the basic understanding? Winds are basically always considered from the direction where they originate. Right? You had a question this year in the mains examination that in Bihar you have during the monsoon months the wind which is known as Purvaya. What is the influence or the impact of it? This was a question in mains this year. Now, Purvaya. Now, in the colloquial language, it basically refers to a wind coming from the east. Now, is any particular place named Purvaya that the wind is named Purvaya? No, it is a wind driving there from the eastward direction. Right. So winds are always named particularly based upon the direction where they originate. In the case of land and sea breeze and mountain and valley breeze, that is where the place is taken that, okay, they are originating from the land, so land breeze, they are originating from sea, so sea breeze. Only in the case of land breeze, sea breeze, and mountain valley breeze will this suffice. Otherwise, if you consider majority of the winds, they don't adhere to this condition. Right. Westerlies are named because they originate from the west one. They appear to come from the western direction. That is why the name westerlies. Polar easterlies are named because they appear to come from the eastern direction. That is why polar easterlies. Okay. No, Kaushik. Only the northeastern and southeastern trade winds are known as the trade winds. Why ITCZ shifts when there is land at equator too, or is it because of the tilt and its revolution? No, if it is, there is a significant amount of land. So there also understand different areas will get heated up to the different proportion. For example, during our summer condition, during the summer season, if I ask you, out of Bangalore and Delhi, which is going to be more hotter during the summer? Always Delhi. Bangalore will experience a moderate temperature of close to around somewhere 25, 30 degrees Celsius, 30, 35 degrees Celsius. Delhi will be baking at 48, 49 degrees Celsius. So their absolute high temperature will be observed in Delhi. Now, both of them are land masses. Why is Delhi getting more hotter? Because of various conditions which influence the temperature. That is why, even over land areas, it can happen that the ITCZ can move based upon which area gets much more hotter. Okay. Uh, Sushmit, I guess it is you from the name of test. So there must be similar anti-directional winds in upper troposphere as per the yes, that is correct. Okay, now, Ankit, I hope it is understood now. And Dikshit, are southeasterlies bringing rains in India? What brings rains in India? I'm not going to tell you now. I want you to develop the entire concept before we come to the Indian monsoon. So, is this portion making sense? Is this portion understood? Why is it that this circulation will happen? This circulation will happen aided by two thermal zones at equator, at poles, that will drive the wind movement. Okay. Now, here, these pressure zones or these pressure cells, they are also named differently. For example, the 30 degrees, the subtropical high pressure belt, again, let me specify, it need not always be at 30 degrees. It can be at 25-degree north during the winters. It can be at 45 to 40 degrees north during the summer. So there's a shifting of pressure belt. So on an average, we consider 30 degrees. So at this region of 30 degrees, these are also what are known as horse latitudes. Most of you would be aware of the reason why. So, horse latitude, the name basically is driven from the anecdote, older anecdote. But first of all, you have to understand the condition here that in the region of high pressure, where you have a sinking air, you don't receive rainfall. There is absolute lack of rainfall. Now, if I can tell you the conditions there, let's suppose, let's suppose when we consider this region, now you have a sinking air in this entirety of the area spanning many kilometers, tens of kilometers altogether, you have sinking air. Eventually, the air will diverge. If you are an individual standing here, will you experience a wind movement if you are an individual standing there? Will you experience a wind movement? Yes. Very easy. If you are an individual standing here, will you experience that wind movement? Yes. If you are an individual standing in between in this area, will you experience a wind movement here in this region? No, you will not. You will experience sinking air, absolutely calm conditions, no rainfall at all. Because for rains, you need clouds. For clouds, you need rising air, which would cool down, condense, and form clouds. So, sinking air, no cloud formation. So, here in this region, you have an absolute calm condition, no wind movement, no rainfall. So, in older days, when the merchants, the traders, they would venture through this area, they would come across, now the older day ships, they were not, obviously they were not steam powered, they were not diesel powered, that they could run through the waters easily. They would basically take the help of the wind movement. The sails would be hoisted and the sails would basically take the help of wind movement. When they would reach this area, they would experience no wind movement at all. Many of the traders, they would get stuck here for many days altogether. And when you are stuck here for many days together, the resource, they start getting lesser, they get scarcer. That is when the traders, in the older days, obviously the traders would carry a lot of horses with them, because when they would get to the land, the horses would be the means of travel. And also for trading purposes also, they would carry the horses. Horses would require a lot of water, resources, food, etc. So what they would do, they would basically kill the horses and push them into the water in this area. As the ship would be stagnant in one region, ship would not move, they would basically kill the horses, push them into the water at one go. When they would do that, not only would they be able to spare some amount of water for the rest of the crew, They would save some resources for the rest of the crew. But the idea was that these many horses, when they fall, that would create a kind of a splash, which would allow the boat to slightly move ahead. And after that, maybe the wind action, etc., can take over them. It is based upon that information or that story that these are named as the horse latitudes. That is why the region of 30 degrees, even today, they are known as the horse latitudes. Okay. Now, here, the 0 degree, they are known as doldrums. That is, the equatorial lows, they are also known as doldrums. Why is it so? So, here, again, the same logic. At the region of equator, the air comes in. Here, the air is rising up because of getting heated. The air comes in, it will also rise up. So, again, apply the same logic. If you are an individual standing here, will you experience the wind movement? Yes? Good. If you are an individual standing here, will you experience a wind movement? Yes? Good. If you are an individual standing here, will you experience a wind movement? No. You will not be able to feel the vertical rise of air. But in this region, there will be a lot of rainfall. Rising air cools down eventually and then condenses to form clouds. We will study about the formation of clouds and rainfall in the next module immediately after this. But here, this is where you again have lack of wind movement, but you will have rainfall. Because of lack of wind movement, here again, many of the sailors would find it incredibly difficult to move forward. That is why they would name this as doldrums. Doldrums is one of the particular names which has stuck around, which has been included in the English vocabulary as well. That is why you will hear the term that my preparation is stuck in doldrums. I don't know what to do, what not to do. Right. So that is the kind of uncertainty, a stagnation which is there. So that is how each of these pressure belts, they are also named differently. India is at between 20 to 30 degree north. We are sinking air. So how rainfall works in India? Is it about the shift of the IDCZ? Yes, Twisha. It is the lack of rainfall around this subtropical high pressure belt. Observe all the regions in the similar latitude to around 30 degrees, 25, 30 degrees. All the major deserts of the world will be there. From the region of Iran, Saudi Arabia, Sahara Desert, Atacama Desert, also some parts, Kalahari Desert, also some part. Then Daste Lut, Daste Kavir, Rubal Khali, all these deserts, Thar Desert, because the region of subtropical high pressure is an absolute lack of rainfall area. So, in the same latitudes as India is, India would have been a desert. Northern portion of India would very easily have been a desert, but for one factor. That one factor ensures that there is rainfall, there is green conditions, natural vegetations grow, crops grow. So there is only one factor which influences the fact that India is not a desert. You have the small Thar desert, but rest of the country is not a desert. But take a look to the same latitude across the world. From the region of Sierra Nevada or Mojave Desert in the region of US to Africa, to the region of Iran, to the region of various parts of Asia, everything is a desert. And that region is river. No, absolutely not. That reason is the Himalayas. Himalayas basically stop the moist winds and cause rainfall. Had Himalayas not been there, India would have been a desert. If Himalayas would not have been there, where would the rivers have got their water from? Think about it. Apply your logic there. In some time when wind flow, that we feel some moisture as well as cold. It depends. It is not always the case of you feel the winds to be moist. Go into the region of Delhi, Chandigarh, there, Ambala, the winds will never be moist unless and until there has been rains or snowfall in the region of the Himalayas. Now, if I talk about these pressure zones, now in real life, in practical real world scenario, can you fathom a creation of an entire belt like this? By the way, whatever we have covered till now is more than sufficient for your general studies portion. Please revise this, more than sufficient. Now we carry the discussion further. In real life, can you fathom the existence of a uniform belt across the planet Earth? You have distribution of land and ocean in various areas, plateaus, mountains, rainier areas, drier areas. Can that uniform belt exist only around 30 degree, only around 0 degree? No. So in reality, rather than these belts, you have pressure zones, high pressure, low pressure zones. Okay. So if you take a look at this image, this is the image of January. January means winter in the northern hemisphere. Pressure zones. So observe this. First of all, observe the ITCZ if you can. This low pressure that you see, trough, equatorial trough. Trough refers to a low. So trough basically crest and trough. That is the term that you use in the case of the folds, the waves also. So equatorial trough refers to equatorial low pressure. This is the equatorial low pressure. This is the equatorial low pressure. This is the equatorial low pressure. Observe that the ITCZ during the month of January comes over to the region of Australia rather than over the equator. Why? Because Australia is experiencing summer as of now. So Australia will be having the winter, will be having the summer season. So this is your ITCZ. Do you need to learn this image? Absolutely not. You need to learn the previous one, the circulation. Now, just next to the ITCZ, you have the subtropical highs. So observe here the high pressure. In the southern hemisphere, they are still very uniform because of dominance of the water body. But in the northern hemisphere, you have the land areas. Now, during the winters, northern winters, all the pressure belts, they shift to the south because the ITCZ shifts to the south. So observe here, you have the Siberian high pressure. Around the region of Siberia, very cold conditions, lack of rainfall. Then here you have the Aleutian high, or not the Aleutian high, but you have the Azores high, or the region spreads around to the Bermuda high also. Then here you have the Hawaiian high around the region of Hawaiian Islands. These are your Hawaiian Islands. That is your Hawaiian high, which slightly shifts. Then the subpolar low around Aleutian Islands, subpolar low, Iceland, Icelandic low, Aleutian low. These are your subpolar low pressure. In the southern hemisphere, again, it is uniform. Why? Dominated by water body. Now, in the month of July, if you observe, in the month of July, that is when you have the summer in the northern hemisphere. So observe this equatorial trough. First of all, it goes through the region of the Sahara towards the northern portion of India. Why? Why not over the central portion of Indian Ocean? What do you think is the reason? Twisha or no, Sushmit? You had the question. Because land gets heated much further as compared to the water body. And this is a thermal low pressure created due to higher temperature. So land will have a higher temperature. Now this is your Bermuda High or Azores High, Hawaiian High. So all these are your pressure zones which drive the winds throughout the entirety of the planet. Okay. Now, after this, we come to the portion of local winds. Now, when we talk about local winds, these are not like the permanent wind system of the trade winds or the westerlies or the polar easterlies that we have talked about. Those particular winds, they would be moving across the entirety of the planet and throughout the year, right? Across the entirety of the planet, and that too throughout the year. That is why they would be known as the permanent wind system or the planetary wind system. In the case of local winds, you have the movement of winds basically over a small area. Movement of winds will be observed over a very small area, over a very small region, and that too for a temporary duration. So wind movement occurs over a small area for a temporary duration. They are known as local wind. By the way, this Saturday, as I had told you in the previous week also, this Saturday we are going to have an extra class. The time and the details will be notified to you, but mostly we will have it roughly from around 7:30. 7:30 onwards, we will have that extra class till around 11:30 or 12. We will carry on the extra session. On Saturday, we will have the extra session. We will see if the need be. We will take the extra session on Sunday morning also. Otherwise, next Saturday, Sunday, we will take the extra session. Okay. Now, these are the factors of local winds. The winds basically which are present in a small area for a temporary duration. Westerlies, trade winds, polar easterlies, they are present across the entirety of the planet, and they basically move through the entirety of the planet throughout the year. They shift. The winds, the permanent winds, they shift, but they are present throughout the year. So that is why they are permanent winds. Here, they are temporary. Now, here also there can be a classification of the local winds into the daily local winds, daily winds, which occur on a daily basis, and then you have seasonal or regional winds. So, here in the case of daily, you will have the examples of the land and the sea breeze, mountain and valley breeze, valley breeze, right? These will be the part of your daily winds. And when we talk about the seasonal regional winds, there are many of them. I have in the end of the PPT, I have provided that list also so that you can refer to it. Because for prelims, this is the portion which is relevant for your prelims. So here, what kind of a question will be asked? I'll tell you about that also. So here, for example, Lu, Mistral, Blizzard, Chinook, Phone, right? Then you have Sirocco, and so on. Harmattan, you have Weld, Best, you have many of them. So in this is going to be relevant for your prelims primarily. In all the local winds, I will show you, I have given you the entire list also. Observe. I have given you along with the map the entire list. This is something which should be used by you for your prelims. Okay? The regions, so Chinook, in which area, whether they are warm or cold, blizzard, Northeast, Santa Ana, in which area, South America, which are the local winds, then Africa, which are the local winds, okay, then Europe, which are the local winds, then Asia, which are the local winds, then Australia, which are the local winds. So like that, I have given you the list that should be used by you for your reference purposes. Few of these winds we will study in greater detail. For the examination, you should be aware about the name of the winds, the region where they are blowing, and whether they are warm or cold. That's it. So, name of the winds, name of winds, regions where in existence, in existence, then also warm or cold. Prelims. Okay. So starting with the concept of the land and the sea breeze. So when we talk about the land and sea breeze, this is a daily occurrence. Now let us understand how does this happen. So basically, when we talk about the land and the sea area, we do know that there is a thermal variation in terms of heating and cooling. Now the land areas, they will get heated quite significantly during the summer. The water body will be much colder during the winter, during the daytime. So the land areas during the daytime will be much more hotter as compared to the water body. We do know that. So here, the land area during the day gets very hot. So here you have the occurrence of a low pressure, right? Water body comparatively is cooler during the day. So here comparative high pressure. So winds always blow from a high to a low. So the winds here will be moving from this high pressure to this low pressure. When they reach this low pressure, they will rise up, form the clouds, cause rainfall, and so on. So here, these are not very large onshore offshore winds. These are very small. So the entire circulation of land and sea breeze does not expand more than around 40-50 kilometers. So you can think about it how small they are, the circulation in comparison to westerlies, trade winds, polar easterlies. These are very, very small. Okay. So here, that is the case where the wind is coming from sea to the land. Wind is coming from sea to the land. And that is where it will be a sea breeze. Sea to land movement during day. Then water during the night time. We do know during the night land will cool down much faster. Water will still retain some heat. Land will cool down much faster. So here now over the land you have the high pressure. Over the water you have the low pressure. No, this is not the case with the rivers. This is the case with the sea and the oceans. So here, during the night time, you will observe that the wind will be moving from that high pressure to that region of low pressure. So here this wind is moving from land to the sea. That is why these are known as land breeze. That is land to sea movement. Movement during night. This is what basically moderates the temperature in the area. It makes the temperature quite significantly moderate. That is why the coastal areas, they don't have the temperature reaching any extremity, because there is a moderating influence continuously in action. Okay. So these will basically not allow the coastal area to experience very high temperature or very low temperature. Then mountain and valley breeze. So during the daytime, here, when we talk about the mountainous regions or the hilly areas, the top of the mountains, they will receive very high solar insolation, so they will get heated up. The top of the hills or the mountains, they will get heated up, so there will be low pressure on top here during the daytime. Okay, during day, they will get heated up. Valley bottom in comparison will still be slightly cooler. In comparison, the valley bottom will still be slightly cooler. So the winds will be driven from the valley bottom towards the mountain top. From the valley bottom towards the mountain top. And that wind, which comes from valley to the mountain, that will be referred to as valley breeze. Now, during night, something reverse happens. When we talk about during night, the mountain tops become very cold during night. Mountain tops, they lose temperature very quickly, so these becomes the zone of high pressure. During night, these areas, they become zone of high pressure. Valley bottoms will still have warmer air, so they become the zones of low pressure. So winds, cold winds will start driving down the mountain slopes, just like valley inversion that we saw. So here they will start driving down. And because they are originating from the mountains, they are known as mountain breeze. Why high pressure? Because they will lose temperature very quickly during the night and they will become very cold. Mountain tops become very cold at night. And that is why it will be a thermal high pressure. So it is originating from the top of the mountains. Hence the name is mountain breeze. Okay. We go to some of the regional local winds also, but we take a break and then after that we initiate. So we take a break and we'll be back in around 15 minutes. So let's take a break. Yes, Ankush, I know. That was an invalid question. So that is why I was waiting for it nonetheless. So let's take a break here, guys, and let's be back. A confirmation about the audio and the video, please. Thank you. Now, now we move towards some of the regional local winds. So basically, here we talk about the temporary local winds which move in only certain areas of the planet, starting with Lu. So when we talk about Lu, Lu is experienced in the northern part of the country. In the northern part of the country to the north of Tropic of Cancer during the summer season. Those of you living in that area would basically recall the advice that your elders, your parents, your grandparents would have handed out to you. That basically, when we talk about the summer season, always in the afternoon, there is this warm wind which blows. And it is always advised never venture out during the afternoon in the summer. You might get impacted by the Lu. So that Lu is a warm wind which blows in the afternoons around 4 p.m., 5 p.m., roughly around that period of time. And it blows in a west to east direction. So here, basically, they move from the west to east direction. So they cross the Thar Desert of Rajasthan. After they cross the Thar Desert of these winds, after they cross the Thar Deserts of Rajasthan, that is when these winds they become much more drier and much more warmer. So here, winds cross the Thar Desert in a west to east direction and become hot and dry as a result. Okay, so they move through the region of India and Pakistan in a general direction from west to east. And that is where these local winds they become particularly dangerous. They cause heat waves, heat strokes that end up influencing lot of population. So these heat strokes basically they cause illnesses in various different people also. Every year we tend to lose a lot of lives because of this impact of Lu. Now, then we come to the local wind which blows in the region of North America. That is, if you take the region of North America here, in this area, if you observe the Rockies, the Rocky Mountains. Now, here, the winds blowing to the east down the slope of the Rocky Mountains. Okay, those are known as Chinook. So here, the winds blowing to the east of the Rockies, east of the Rockies. So here, when you talk about the region of the Rocky Mountains, any mountain for that matter, any mountain or a hill will have two sides. One which faces the wind, that is known as the windward side. This is the windward side. And the one which is to the opposite of it. That is what is known as the leeward side. So basically, from the windward side, here, as the winds they rise up, here they will cool down, maybe lead to condensation, cause rainfall in this area. As the winds here, they will rise up. They will significantly cool down, right? All the water vapor, because of that cooling, will get converted into liquid water droplets or solid ice particles, will lead to cloud formation. They will bring rainfall. So windward side of the mountains, anyways, they face lot of rainfall. But the wind which emerges here, can we say that this wind is now dry? Because all the water vapor has been utilized for the cloud formation and for bringing rainfall. So this is going to be a dry wind. Because all the water vapor has been utilized. So here, this dry wind, as it comes down, the temperature of this wind will increase or decrease as it is coming down the mountain slope. The temperature of the wind will increase or decrease. Very good. It will always increase. Why? Why will it increase? And those of you who are saying decrease, let me know why is it that you think that it will decrease? Very good. So here, this will get warm due to adiabatic heating or adiabatic compression. So adiabatic heating will be observed. This adiabatic heating will increase the temperature. So in this case, temperature rises up. Temperature tends to significantly rise up. So by the time that it comes down to the slope of the Rocky Mountains, the eastern slope of the Rocky Mountains, its temperature would have increased to a sufficient degree where it would lead to the melting of the ice which had been accumulated over this area. That would lead to the melting of the ice. And that is why these winds, they are also known as the snow eaters, as they melt the underlying snow. So the basic Chinook wind is, these are warm and dry winds blowing on the eastern slope of the Rocky Mountains. They come down the slope. They come down the slope. Temperature increases. There is adiabatic compression. Compression occurs. Temperature increases. Okay. So that is why they will lead to the melting of snow. Now, a similar phenomena is also observed in the region of the Alps. Observe the Alps here. Now, in the case of the Alps, the leeward side will be the northern slope. In the region around Switzerland, that is where you will have the northern slope. So in the region of the Alps, you have again the same phenomena, just like Chinook, but these local winds are known by the name of Fohn. So here, a warm and dry wind like Chinook is called Fohn along the northern slopes of the Alps mountain. Here also, the same process, the same phenomena you will observe, that basically you have the southern slope of the Alps, and you have the northern slope. Okay. So here, as the winds here will rise up, they will cool down. Whatever moisture, less moisture, little humidity, whatever they are carrying, that will get converted into cloud, will lead to snowfall and precipitation in these areas. Whereas here, the winds will become dry, and as they come down, the winds become significantly warmer as well. So that is why in the northern slope of the Alps in the region of Switzerland, they basically create a condition which is significantly warmer. Now, either ways, they would have been covered in snow and ice. But because of these warm winds, they create a condition where you can go for early planting of the crops also, early ripening of the crops also will happen. And they are more common during the months of spring and autumn in Switzerland. Weather becomes quite pleasant in the valleys due to the melting of snow. Therefore, valleys of Switzerland are known as climatic oases. Oasis, you would have heard about the term oasis in deserts. What is oasis? Have you heard about the name oasis? Basically, yes? Okay. Oasis is the small water bodies, the small ponds that you find in the middle of the desert where they are supposed to provide you some relief. So, similarly, here, all across, all around the area, because the conditions are very cold, in this particular small area, you will have warmer conditions, pleasant conditions, right? So, that is where it is referred to as the climatic oasis also. Now, therefore, these winds help in early sowing of wheat, ripening of grapes, and check autumnal frost. They don't allow the frost formation to happen so significantly. That is the case with Fohn. Similarly, in the region of the Iberian Peninsula and also in the region around France and Spain, that is where, particularly during the winter months, in the winter months, Mediterranean is going to be a bit warmer. Land area is comparatively going to be colder, right? Because during winter, land becomes much cold, water continues to stay warm. So during the winter months, when the land becomes very cold, they become regions of high pressure. And from that high pressure, winds are driven towards the region of Mediterranean. These are very cold winds which lower the temperature to sub-freezing degrees in the region of Europe. Okay, so Mistral is a cold local wind which blows in Spain and France from northwest to southeast direction. They are more common and effective during the winter season because of development of high pressure over Europe and low pressure formation over the region of the Mediterranean Sea. Now, arrival of Mistral causes sudden drop in air temperature to below the freezing point. Okay. Now, then we also have blizzard. Blizzard is quite common in the region of the tundra or the Arctic region in particular. So, experienced in the region of North America, in the region of Europe, in the region of Siberia, Northern Asia, where the cold polar winds they start blowing southwards. Particularly during the winter, the cold winds they become very predominant. They start flowing and blowing southwards. And as these cold winds they start coming southwards, that is when they lower the temperature. There will be significant snow formation, ice formation, and these winds, when they move at a speed of 80 to 100 km per hour over the region of snow and ice, they will carry small particles of snow along with them. So it will be that powdery snow which shall be carried by the winds altogether. And that lowers the visibility, significantly lowers the temperature. The temperature plummets all of a sudden, right? So it is a violent, stormy, cold, and powdery polar wind laden with dry snow and is prevalent in North and South polar regions, Siberia, Canada, and even the US. If you observe the region of the US, ideally, US should not have been impacted. These cold winds influence these northern areas. Okay, they influence these northern areas. So US is significantly southwards. It should not be impacted. But in the region of US and North America, you observe Appalachians to the east, Rockies to the west. There is no mountain range in east to west direction like the Himalayas. There is no such barrier like this. So as a result of that, these winds, they are able to penetrate and even hit the region of US. That further and particularly makes the winters very, very cold in the region of US. In fact, last year, you would have come across the very sad news story where an Indian family of you had a young couple along with their child. Now they were migrating illegally from the region of Canada to US, and they were basically going through the land route, not the normal transportation route, but they were simply going through the forested area, and they were trying to cross from Canada and enter into the border of the US. It was then that they got stuck because a blizzard took over, and eventually all of them, they froze to death. Right, it was a very horrendous and a sad case where you had the entire family getting impacted by this, freezing to death. So blizzard can be that dangerous. Transportation sector gets impacted in North America because of that blizzard. It is because of this reason, by the way, here, if you observe the region of Canada, if you observe this area of Canada, for example, I hope you are aware that more than 90% of the Canadian population lives in this area, its southernmost boundary. More than 95% of the Canadian population. This area is sparsely populated. Nobody lives there. Some population will still live in these areas because of the westerlies and the coastal conditions. The climate becomes a bit tolerable. Very few population portion, but majority of the population in Canada resides here. Right? This is almost vacant land. So that is how the winds, they impact the factor of even human geography, where people live, what is the population distribution, etc. Okay. Now visibility becomes remarkably low because of snow and ice crystals. The velocity ranges between 80 to 96 kilometer per hour, and there's a sudden drop in air temperature to sub-freezing level. Thick cover of snow on the ground surface, and there is an onset of the cold waves which are accompanied. Then you have another warm local wind, which is known as Sirocco. Now, Sirocco is in motion over the region of North America, North Africa. Now, from the portion of North Africa, as this Sirocco moves, they pick up red sand from the region of the African desert. They pick up red sand, and then they cross over from the Mediterranean. As they cross the Mediterranean, that is when they pick up moisture as well. Substantial amount of moisture is picked up. Now these moisture and red sand laden winds, they hit the Italian coastline and the European coastline. And that is when you will observe that they cause rainfall in the Italian coastline. But the rainfall that they create in the Italian coastline, there, these red sand particles that they had carried, they make the raindrops appear reddish in color, reddish in nature. That is why these are also what are known as blood rain. So Sirocco is associated with the causation of blood rain. So when we talk about Sirocco, it is a warm, dry and dusty local wind. The sand that it carries or picks from the region of Sahara is generally the red sand, which blows in the northerly direction from Sahara Desert, and after crossing over the Mediterranean, it reaches the region of Italy, Spain, and so on. So while passing over the region of Mediterranean Sea, it picks up moisture and yields rainfall in the Italian peninsula, where the arrival of rain is associated with what is known as blood rain. That is what is referred to as blood rain because of fallout of red sand with the case of falling rains. So that is the case of Sirocco. So these are few of the local winds. Accordingly, just observe the regions and whether they are warm or cold. That will be more than sufficient for your requirement of the examination. Okay, just this much information and idea is more for your prelims. Okay. Now, after this, we come to the portion of humidity and precipitation. Why red rain occurred in Kerala in 2000? That is a part of the acid rain. That is the part of the acid. And many of the times in the local conditions, if you have these red rain, that is basically some of the times the sand particles, etc., that are carried, that becomes a part of it. How does Lu form? Lu basically is formed if you observe in the region around the Sistan Balochistan area. There you have the high pressure. And during the summer season, the entirety of North India experiences very high temperature. That is the northern plains, they experience very high temperature. So there is substantial low pressure over the entirety of the northern plains. From the Sistan Balochistan province, which is the mountainous area, a hilly area in the western portion of Pakistan, bordering Iran, there, from that high pressure, the winds they start to blow. And these winds they cross the dry Thar desert area, and their destination is this low pressure. That is why the entirety of northern India experiences this warm, and basically they tend to experience this dry and hot winds. Okay, that is how Lu gets created. Now, can we take questions from this? Let's take few questions here. So, what causes the winds to deflect to the left in the southern hemisphere? Why is it that the winds will deflect to the left in the southern hemisphere? I expect all of you to get it correct, but expectations are oftentimes met with disappointment. At least 80% of you should get it correct. Okay. Many of you think that it is because of the pressure that the winds will deflect to the left in the southern hemisphere. Okay. Why is it that the winds deflect to the left or to the right in the southern hemisphere? It is because of Coriolis force. Let me tell one thing, guys. Many of you will, if you will not revise, you have reached that level of saturation. Let me be very honest. Many of you have reached that level of saturation where you will start to zone out, where after some time, whatever is being said will fall on the ears, will start bouncing back. So there is only one cure for this: revise. If you revise today and tomorrow, the remainder of the classes will still be productive. If you are having the plan that right now I have to meet the chief minister, tomorrow I have a cabinet meeting with, and then prime minister, I have to take important decisions. If you have pushed that plan of revision to after the module completion, let me assure you, many of you are in the stage where it will stop making sense anymore. So please do revise. Unless and until you revise, there is no benefit out of it. Please do revise. Okay. So here, Coriolis force is because of what? Rotation of Earth. Okay. So here the correct answer is C. Westerlies in the southern hemisphere are stronger and persistent than in the northern hemisphere. Why? Southern hemisphere has less land mass as compared to the northern hemisphere. Coriolis force is higher in the southern hemisphere as compared to the northern hemisphere. Why is it so that westerlies are stronger in the southern hemisphere? See, these sort of questions are asked in the examination. If you are able to answer this, fair enough. Good. At least a majority of you have given the correct answer. So why is it that the westerlies are stronger in the southern hemisphere? Because of less landmass in the southern hemisphere. That is why they are very strong. Now, Coriolis force is higher in the southern hemisphere as compared to northern hemisphere. That is not the case. So the Coriolis force acts equally. Then there are other factors which contribute to the strengthening or weakening of the Coriolis force. But that does not make the Coriolis force is not the reason why the winds are stronger or weaker. Winds are stronger because of lack of frictional force over the dominant water body. So here the correct answer is going to be A, one only. Now, a layer in the atmosphere called the ionosphere facilitates radio communication. Why? Why ionosphere facilitates radio communication? That is the question. Listen to me very carefully. The question is why ionosphere facilitates radio communication. Okay? That is the question. The presence of ozone causes the reflection of radio waves back to Earth. Radio waves have very long wavelength. Which of the statements given above is or are correct? Okay. So majority of you have given the incorrect answer. Very good. So here, basically, why is it that ionosphere will facilitate radio communication? That is the question. Ionosphere facilitates radio communication because of simple reason due to presence of ions. Ions. That's it. Okay. Now, whatever is the nature of the radio waves, it is basically because of presence of ions that the communication will be facilitated, that the reflection of the radio waves will happen. So the presence of ozone causes the reflection of radio waves? No, you have the presence of ions there. So that is going to be incorrect. Then radio waves, they have a very long wavelength, regardless of whether they have a long wavelength or short wavelength. If long wavelength would only have been the reason, why to get reflected from the region of the ionosphere? Why not from the lower layer? So it is purely because of the presence of ions. So this is also incorrect. So the correct answer is basically D, neither one nor two. The jet aircraft flies very smoothly in the lower stratosphere. What could be the appropriate explanation? There are no clouds or water vapor in the lowest or the lower stratosphere. There are no vertical winds in the region of lower stratosphere. Majority of you have given the correct answer. So here the correct answer is C, both 1 and 2. That will be the correct answer in this situation. So no clouds and no vertical movement means there is a stability. That is where the jet aircrafts can fly easily. Now the leaderboard. Very good. Beautiful. So, with that, we come to the next module and we start the discussion with the humidity and precipitation. For your prelims, basically, you will have the areas associated with basics of condensation, types of humidity, the basics, absolute basics of them. Then dew formation, nature of clouds, then types of rain, and then types of fog. So these are the portions which are going to be relevant for your prelims. For your mains examination in this area, you will get questions around the region of cloudburst and hailstorms, hailstorms, types of rainfall, types of fog, dew formation, okay. These are the areas which are relevant for your mains examination. These are the portions that we will be covering in this particular chapter. We start the discussion with the portion of humidity. What do we understand when we talk about humidity? What is meant by humidity? Humidity basically is the amount of water vapor or moisture which is present in the air. In any air sample that you consider, the total amount of moisture, the total amount of water vapor which is included, that is what is regarded as humidity, right? Now, amount of moisture, amount of water vapor, that can vary, that can be dependent on many different factors. But basically, the amount of water vapor is what we refer to as humidity. There are various different ways in which we measure humidity by considering 1 meter cube or volume of air, by measuring what is the carrying capacity of air. So there are various mechanisms by which you can come to the conclusion of the types of humidity. But humidity is the amount of water vapor. Now here, humidity gets impacted by temperature. How? So when we talk about it, basically, let's suppose you have a parcel of air. Let's suppose you consider a parcel of air. Now in this you will have air molecules. In this you will have air molecules, the gaseous molecules. In between these gaseous molecules, wherever the spaces exist, you will have the water vapor particles also. You will have the water vapor particles also in this, isn't it? Now let's suppose you heat this air parcel. Let's suppose that this air parcel gets heated up. So as you heat this air parcel, the particles will gain some energy. The particles might disperse. So here, you might have lesser number of particles altogether as compared to earlier. So what will happen? Now there is a capacity to accommodate more moisture. More water vapor can be accommodated here. Much more amount of water vapor can now be accommodated here, isn't it? So what has happened? In a way, can we say that the carrying capacity of air has increased? What is carrying capacity? The amount of air, the amount of moisture that the air at any given temperature can carry. That is the carrying capacity of air. So when we talk about the term carrying capacity of air, what is meant by that is basically carrying capacity means the total amount of moisture or vapor that an air parcel can accommodate at any given temperature. That is what is known as the carrying capacity, the total amount of moisture or vapor that the air parcel can accommodate. Now, let's suppose we have heated it. So, upon heating, what has happened? Upon heating, can we say that the carrying capacity has increased? Why? Because the air particles, they will disperse, opening up more spaces. So, in those more spaces, more particles can come in, isn't it? So we can say that the carrying capacity has increased due to heating. Let's suppose I cool this air parcel down. Let's suppose I cool it down. There is cooling. Now, upon cooling, what happens? The particles, they come very close to each other. So now, the space available for the water vapor has reduced in comparison. Only in this much space the water vapor can be accommodated. So what can we say about the carrying capacity? Can we say that by cooling, the carrying capacity has decreased because now the particles are much closer to each other? By heating, the carrying capacity of air has increased. That means it has got the accommodation or the capacity to accommodate more of the vapor. So that is where the humidity and temperature, they influence basically water carrying capacity of an air parcel varies with the temperature of air. A warmer air parcel can hold more amount of vapor as compared to a colder air parcel. Excuse me. So a warmer air parcel can always accommodate and can always hold more amount of vapor. Now, humidity is something that we basically experience. We experience the discomfort, the various influences due to humidity, but we don't realize that it is because of the factor of humidity. For example, you would have experienced during, or if you visit the coastal areas, Mumbai, Goa, uh, Trivandrum, Chennai, Vishakhapatnam, Kolkata, Puri, in these coastal areas, you would have observed that the temperature is not as high as maybe a Delhi or a Chandigarh, but it becomes very oppressive or unbearable. When you perspire or when you sweat, that sweat doesn't evaporate. Evaporation of the sweat is body's own internal mechanism to cool down the temperature of the body. But that sweat doesn't evaporate because the air is so very full with water vapor that no more vapor can be provided. After all, evaporation of sweat will also be a kind of water vapor supplied. So it won't evaporate. You will be left feeling a lot of discomfort. But go to maybe a Chandigarh or a Ludhiana, Ambala. Temperature oftentimes they exceed 45 degrees, 40 degrees, 45 degrees, 46 degrees, oftentimes. Now, in that high temperature, still the air is very dry. So you will perspire, you will sweat, but that sweat keeps on evaporating. So the body keeps you cooler. Natural cooling is there. In coastal areas, you feel that kind of discomfort. In the rainy season also, if you recall your period duration or the time that you spend during the rains, during the months of June, July, you go out to play, right? Any sport that you go out to play, you will sweat a lot and you feel dehydrated because that loss of water is happening. The body's internal temperature keeps on increasing. So, humidity influences human health also. In regions such as Bangalore, in these months, particularly January, February, March, the air becomes so very dry. It becomes so very bone dry. Humidity is roughly around 20%, 15%, 25% in that range. So there, the skin starts to become dry. The skin starts to peel off, right? You will find that if you are living in the regions such as Bangalore in these months, or even Pune for that matter in these months, you will find that static shock is something which is very common. You touch something, you will feel some electric shock, right? It was reported in the national newspapers also last year. Why? Because the dry conditions mean oftentimes there is the charge which develops. So, a humidity level of 34-40% is healthy for the human skin, for the human body. Humidity level below that becomes very dry, very oppressive. A humidity level to the range of 80 degrees, 90 degrees again becomes oppressive. Okay. Now, when we talk about this humidity, how do you measure that humidity level? So, there are different ways in which you measure. One of the ways is basically when you talk about it, one of the ways can be that you take one unit volume of air. You consider 1 unit volume of air. Let's suppose 1 meter cube. In this 1 meter cube, what is the weight of water vapor? Let's suppose. What is the weight of water vapor in this? That you calculate. Let's assume it is 5 grams, 10 grams. Let's assume it is 5 grams. So basically, the humidity in this case will be 5 gram per meter cube. This is one of the ways. Another method to measure that humidity can be let's consider 1 kg of air. Rather than 1 meter cube, let's consider 1 kg of air. 1 kg of air can have any dimension, any particular dimension. 1 kg in the sense that you measure out the weight of the particles. So here 1 kg, let's suppose, of air. In that 1 kg of air, what is the presence of the vapor particles? Let's suppose in this 1 kg of air, you have 15 grams or 10 grams. So that will be how much? 10 gram per 1 kg. So both of them are units of weight here. So it will be 10 gram by 1000 gram. So this can be expressed in 10 parts per thousand. This is indicative of parts per thousand. Out of 1000 grams, you have 10 grams of vapor. So this is parts per thousand. Okay, this is another way by which you can measure humidity. There is another method, and that method is, let's suppose you consider an air parcel. Let's suppose you consider an air parcel. And you find out that at any given temperature, what is the carrying capacity of moisture? Carrying capacity of air. At this given temperature, let's suppose the carrying capacity is 10 grams. That at this temperature, air can hold 10 grams of vapor in it. But what is actual present amount of vapor? So actual present amount, present let's suppose is 5 grams. So what will be the relative? So this is your relative humidity. So in comparison to the total carrying capacity, what or how much amount of it is the air holding as of now? So this will give you relative humidity. Humidity. That comes out to be 5 by 10 into 100. That is 50%. So the air is holding 50% of the moisture content. 50% means there is a scope for having 50% more moisture. Okay, so there are different ways in which you can measure humidity. One of the ways is when you take the volume, fixed volume, and in that fixed volume, you basically consider what is the weight. This is known as absolute humidity. Absolute humidity. Another method is when you consider a fixed weight of the air, and in that fixed weight, what is the amount of moisture present? That is basically your specific humidity. And then you have another one in which you measure the amount of moisture in comparison to what is the carrying capacity. How much of it is that the air can naturally hold? So that is basically the case of relative humidity. Clear? Now, from here, let me ask you a question. I hope you are comfortable up till now. Are we comfortable, guys? Okay. So, absolute humidity is the total weight of moisture present per unit volume. Now, if I compare two regions, equator and poles, think about it carefully. Take your time, think about it carefully. Let me know, as you move from equator to the poles, absolute humidity, will it increase? Is it increasing? Absolute humidity, or does it decrease? What happens as you move from equator to the region of the poles? I will give you 1 minute of time to think about it. Think about it carefully and let me know. The absolute humidity, basically, is it going to increase? Is it going to decrease? Yesterday, I had a complaint that I'm not giving enough time. So for this, I'll give you enough time. Do let me know. I need you to be convinced of the reason also. Think about the reason. As you move from equator to the poles, absolute humidity increases or absolute humidity decreases. If increases, why? If decreases, why? Good. Good. So basically, it will tend to decrease. And what is the reason for this? That as you move from the region of equator to the region of the poles, the temperature will reduce. Temperature reduces. As the temperature reduces, the carrying capacity will also reduce. So naturally, the air will hold less amount of moisture under natural conditions. That is why you will observe that the absolute humidity tends to decrease. Okay? Now, this is the definition of it, the absolute specific humidity. So, absolute humidity, total weight of moisture content per volume of air expressed in gram per meter cube. It decreases from equator to the poles. Specific humidity is the mass of water vapor per kilogram of air. Per kg of air, what is the total mass of water vapor? And that is the quantity of moisture present. It is seldomly affected by the change in volume and temperature, because there 1 kg, if let's suppose it is cooled down, so 1 kg will cover a smaller dimension, or warmed up. So 1 kg of air you are considering. So that is why it is almost consistent. Then you have relative humidity. Relative humidity, basically the ratio of the amount of water vapor present in the air to what it can overall hold within itself. That is what is relative humidity. Okay. Now, let us study this relative humidity a bit more, because when you open up the news headlines, when you hear the news reports that the humidity levels are at 60%, there are chances of rain. Humidity levels are 34%, no chances of rain. So that is the relative humidity that we are talking about. Okay. Now, will this relative humidity be impacted by temperature? Yes or no? What do you think? Very good. This will be impacted by temperature. So what is relative humidity? Relative humidity is a ratio of amount of water vapor present in air to what it can hold. So what is the vapor present? Vapor present by carrying capacity into 100. That is the relative humidity. Now, with the change in temperature, this carrying capacity, that can change. We know that warmer air will have a greater carrying capacity, colder air will have a lesser carrying capacity, isn't it? So let's consider an air parcel at a temperature of 30 degrees Celsius. Temperature of 30 degrees Celsius. Let's suppose carrying capacity at this temperature is 12 grams. Vapor present is 4 grams. So what is the relative humidity in this case? What is the relative humidity in this case? 4 by 12 into 100. That will be 33%. Fair enough. Now, let's suppose I cool it down. I bring the temperature down. I lower the temperature to 20 degrees Celsius or 25 degrees Celsius. Let's suppose due to the reduction of temperature, carrying capacity has reduced to 10 grams. Vapor present was 4 grams. So what will be the relative humidity in this case? Very good. 4 by 10 into 100. How did you arrive at 80? Under no method can I calculate this to lead to 80. This is 40%. Okay. So upon cooling of air, what has happened to relative humidity? When I have cooled down the air, relative humidity has increased, isn't it? Now, let's suppose I heat the air parcel. I take the temperature to 35 degrees Celsius. Carrying capacity becomes 16 grams because with heating, carrying capacity will increase and vapor present remains 4 grams. What is the relative humidity in this case? Very good. So relative humidity in this case comes out to be 25%. So upon heating, basically what has happened? From the earlier scenario, when you heat it up, relative humidity reduces. What does that mean? That there is a scope of more moisture to be accommodated in the air. Now the carrying capacity has increased to 16 grams. Vapor present is only 4 grams. More moisture can come into that area. Much more moisture can be accommodated. Relative humidity, when you have carrying capacity of 12 grams, upon cooling has reduced to 10 grams. Right? So like that, relative humidity is influenced by temperature always. If the temperature increases, there is a greater carrying capacity. The air will be able to carry much more amount of moisture. Whereas when the air cools down, its ability to carry more moisture keeps on reducing. That brings us to the concept of saturation of air. Now, what is this saturation of air? So basically, I hope I don't need to write it down that upon cooling, upon heating, what will happen. I hope you are able to recollect that. Okay, right? Kaushik, when we study the portion of Indian monsoons, you will understand that basically, as you move away from the source of water body or sea, that is when it becomes the case of drier air is more persistent or prevalent there. Why absolute and specific humidity? Absolute humidity is impacted by temperature. Absolute humidity will be impacted by temperature, Likhani. Specific humidity won't be impacted because absolute humidity will influence is the total amount of moisture present. That is the amount of absolute humidity. When we talk about specific humidity, we are talking about 1 kg of air. So let's suppose by heating or cooling, even if there is expansion or contraction, 1 kg will remain that intact 1 kg. Particles will be, if let's suppose 1 kg of air means 1 billion particles, 1 billion particles will be considered. So there, in that 1 billion particles, whether there is a scope to accommodate more or less, that will also be consistent. Now, here, basically, we come to the saturation of air. Saturation. Anything which is saturated means what? There is no capacity to include anything more in it. That is what saturation indicates, after all, isn't it? So, when we say saturation of air, basically, that is when the air is completely filled with whatever moisture it could carry. It doesn't have the scope to carry any more amount of moisture anymore. So saturation of air is basically the air containing moisture to its full capacity at a given temperature is said to be saturated. So saturated air will have a relative humidity of how much? What will be the relative humidity of saturated air? Very good. It will be 100%. Why? Because air is carrying as much amount of moisture as the carrying capacity. Air carries as much moisture as the carrying capacity. That is why it is said to be saturated. Now let's suppose we consider certain situations here also. Let's suppose I have an air parcel. Now, let's assume it is at a temperature of 30 degrees Celsius or 35 degrees Celsius. Carrying capacity is 10 gram. Is 10 gram. Vapor present is also, let's suppose, 10 grams. I can say that the air is saturated in this case. But what if I heat it up? I carry out some amount of heating, let's suppose. Then what happens? Then this air parcel, let's suppose temperature due to warming of land has increased to 40 degrees Celsius. Carrying capacity has increased to 15 grams. Vapor present was 10 grams. So what is the relative humidity now? It is 66%. 66.67% will be the relative humidity in this case, isn't it? So here can we say that saturated air, when it gets heated, it becomes unsaturated? Can we say that it becomes unsaturated? Now, the converse of it. Let's suppose I cool this down further. I carry out cooling. Now, in the process of cooling, let's assume in the process of cooling, you will observe, let's say, the temperature to be taken down to 30 degrees. Carrying capacity has reduced to 8 grams. Okay. Vapor which was present was 10 grams. Now, the carrying capacity of air is only 8 grams. Vapor which was present was 10 grams. Now, what will happen? Will that extra 2 grams of vapor be accommodated? Can we say that in this case you will have extra 2 grams? What will happen to these extra 2 grams? Will it be like the local train that you will be asked to adjust, please adjust, let this 2 grams get accommodated? No. These 2 grams will condense. These 2 grams get condensed. So that is where condensation happens. So this is basically condense. Condensation occurs. So whenever an air cools down, what happens to the relative humidity? When you have cooling of air, relative humidity, we do know that it increases. Cooling of air leads to an increase in relative humidity. So when the air cools down, its relative humidity keeps on increasing. It will reach the point of saturation. If it cools down beyond that, if the air cools down beyond that, that is when condensation shall be initiated. So that is basically the crux of the matter. That is, cooling of air increases the relative humidity. It reaches eventually to the point of saturation. Saturation. If it cools down beyond that, condensation happens. Comfortable up till here? Are we comfortable up till this point? Good. So when the air rises up, now let us try to interconnect the logic and the concepts. When the air starts to rise up, its temperature will start to reduce. due to adiabatic expansion. When the air begins to rise up, its temperature will begin to reduce, isn't it? Now, as the temperature reduces, its relative humidity will keep on increasing. It rises to a level of 2 kilometers, relative humidity increases. 3 kilometers, relative humidity increases. If it rises to a point where the relative humidity finally reaches around, let's suppose, 100%, air is now saturated. If it rises even slightly more, slightest of the reduction in temperature, if it is observed, what will happen? Condensation will happen. Now, an air parcel consisting of 10 grams of moisture, an air parcel consisting of 5 grams of moisture, will condensation happen at the same level, or will condensation happen at different levels? What is your point of view? If you have an air parcel having the amount of moisture as 5 grams, an air parcel having the amount of moisture as 10 grams, as they both rise up, will the condensation happen at the same level or different level? Very good. Condensation will happen at different level. So as the condensation does happen at different level, basically what does that mean? That is why you observe all the clouds. Not all the clouds are formed at the same level. The clouds are created at different heights, at different levels. Right? So that is the aspect of when condensation tends to happen. Now, condensation is something that we observe in our day-to-day lives. We have talked about it previously also, but condensation is something that we experience quite regularly. So, for example, let's suppose you take a bottle of water and you keep it out. Let's suppose you take that bottle from the refrigerator and you keep it outside. Let's suppose. Now, in the refrigerator, the bottle was experiencing a temperature of 1 degrees, 2 degrees, or 0 degrees, maybe. Right? You have kept it outside. After some time, you will observe tiny water droplets. They start developing on the water bottle. Soda bottle, water bottle, cold drink, anything. You would have experienced this. Tiny water droplets, they start developing. Have you ever thought about it? Where do these water droplets come from? Has that thought crossed your mind? That where is this water droplet coming from? Where is the water droplet coming from? It is basically from the surrounding air. The surrounding air basically cools down. So when you have the water bottle that you have kept outside, its surface temperature might be very low. Its surface temperature might very well be around 2 degrees, 1 degree Celsius. Now the air around it will be heated, will be cooled down. Air is cooled down. It reaches saturation. Saturation. Cools further. Causes condensation. Now that means condensation can occur at any temperature. Condensation can occur at any temperature as soon as the saturation limit is reached. Now, if you have two air parcels, the question that I had asked earlier, let's suppose you have two air parcels, A and B. A and B. Now, A has got a relative humidity of 60%. B has got relative humidity of 80%. Let's suppose. Now, if let's suppose cooling is to happen uniformly, condensation will occur here much earlier, right? So, greater the moisture content, condensation occurs quicker, right? Condensation can start occurring very, very quickly. Now, this also brings us to the concept of dew formation. Now, in the coastal areas throughout the year, but in the rest of the country during the winter months, you would have observed that tiny droplets of water, they start getting deposited on the blades of the grass, on the surfaces, the metal surfaces, etc., that you have kept around. Tiny droplets of water, they start accumulating. What are those? Those are dew. How are those dew formed? How are those dew drops created? By condensation. Why? So the air right now, for example, it is winter in majority of the part of the country. So almost all of you would be experiencing this, that late at night, early in the morning, the soil gets a bit damp. The blades of grass, they get a bit damp, they get a bit moist, wet. Let's suppose you have parked your car outside, the car will have that sheen of water droplets, giving it that kind of a wet and a damp surface appearance. All of that is very apparent. So, why does that happen? That is basically dew formation. So, when during the winter nights, generally the temperature reduces, and as the temperature reduces, the air will tend to reach saturation. As the air reaches saturation, if the temperature reduces in the night beyond that, there will be dew formation. So, for dew formation, the ground surface has to lose heat very rapidly. So, when we talk about dew, basically tiny drops of water that form on cool surfaces at night when atmospheric vapor actually condenses. The dew point is the temperature the air needs to be cooled to. At what temperature should the air be cooled to in order to achieve a relative humidity of 100% or point of saturation? Point of saturation. Let us understand this. For example, if you go to Vishakhapatnam, dew formation you will observe throughout the year. Every day in the evening, you will observe dew formation. But if you go to the region of Delhi, Chandigarh, Lucknow, Patna, you will observe dew formation only in winter. Why is it so? So, understand. Listen to this carefully and try to understand. Let's suppose we consider Vishakhapatnam. Or, okay. I hope nobody gets offended if I write Vizag here. So, here, let's suppose. Now, it is a coastal area. Vishakhapatnam is a coastal area. So the amount of humidity in the coastal area will be very high. Throughout the day, there is evaporation from the coastal area. So amount of humidity will be very high. So let's suppose relative humidity is 80% at a temperature of 35 degrees Celsius. Now, during the evenings, the temperature will reduce. Let's suppose the temperature reduces. The temperature reduces to 30 degrees. Relative humidity will tend to increase upon cooling. So relative humidity, let's assume, has now reached 100%. Let's assume. Now by night, obviously the temperature will reduce a bit more, isn't it? Let's assume this is at 3 p.m. This is at 5 p.m. So let's assume at 7 p.m. or 8 p.m. temperature reduces to 26 degrees. Or why to take 26 degrees Celsius? Let's assume 29 degrees. 1 degree Celsius temperature drop. Relative humidity has already reached 100%. This is the point of saturation. Now, if you cool it beyond that, there will be dew formation. So here the dew has been formed at 29 degrees itself, right? But at 29 degrees, you won't observe the dew formation in Delhi or in Bhopal or in Indore or in Lucknow or in Jaipur. None of the inland areas, you'll find the dew formation to be present at 29 degrees. Why? Because it is only in the coastal areas where the air is naturally so humid and moist that dew formation is allowed. But let's suppose we consider the region of Delhi. Now, if you consider Delhi here, having a temperature of, now Delhi is generally dry, relative humidity of 40%. Temperature, let's assume, is 40 degrees Celsius. Now you cool it down. So if it cools down to around 25 degrees Celsius, maybe the temperature cools down to 25 degrees Celsius. Relative humidity, let's assume, reaches 65%. You cool it down further, cool it down to 15 degrees Celsius. Relative humidity maybe reaches 90%. Cool it down further, take the temperature to 8 degrees Celsius. Then let's suppose relative humidity reaches 100%. This is your point of saturation. Now, if the temperature reduces even to 7 degrees Celsius, there will be dew formation. So what does this tell you? That when the air is dry, whenever the air is dry, it takes a lot of cooling down for the air to reach saturation. And that can happen generally during the winter months only. That is why dew formation in those inland areas, in the continental areas, dew formation is largely witnessed only in the winter months. Okay, that is when it is experienced only in the winter months. Whereas in the coastal areas, where you have the marine influence, in those areas, dew formation can happen quite regularly every day, evening time. Dew formation can easily occur. Okay. It can also condense at 8 a.m. Generally, the condensation of the last night itself are visible at 8 a.m., 7 a.m. Ankush, so Delhi, do Delhi temperature fall at this extent? Absolutely, yes. During the winter months, the temperature drops. Okay, right? Is it clear up till now? Very good. Now, we come to the cloud formation. So, cloud formation is again the same process of condensation which occurs. That same process of condensation leads to the formation of clouds also. So, when we talk about the cloud formation, there it is dependent upon the fact that air has to cool down so significantly that it cools down beyond the point of saturation, that it cools down even after attaining a relative humidity of 100%. So, for that, what does the air have to do? The air has to rise up. That is why clouds will only be observed wherever you have a rising air column. Okay, so only to be observed in regions of rising air column. Wherever the air is actually rising, that is where the temperature of the air will drop. And as the temperature of the air drops, that is when it will start to condense. Right? So, how does that cloud formation take place? Let us understand this. So, let's suppose you consider this to be the ground surface. Let's suppose. Now, here, let's assume that higher up you have the presence of dust particles. Some dust particles are present in the higher elevation also, at an elevation of maybe 5 kilometers, 4 kilometers. Now, these dust particles, will they be having low temperature on the surface, or will they provide a warm surface? What do you think? These dust particles, will they provide a cold surface, or will they be providing a warm surface? Why warm or why cold? Was it because of 50-50 choice was there? So let's pick up one. No, I'm only talking about the dust particles. Dust particles are present everywhere. So at a elevation of 5, dust particles have drops of water, do they? No. Simple reason, it will be cold. Very simple reason, it will be cold because they are at a particular height. They are at a particular altitude. That is why it will be cold. Now, from the ground surface, let's suppose the air has started rising up. The air has started to rise up. Now, as the air has been rising upwards, in the process, the air will cool down as well, right? Maybe it will reach the point of saturation. It will cool down. It reaches the point of saturation. It rises further. All the water vapor in that case will condense. If, let's suppose, the temperature is below freezing point, let's suppose temperature is below freezing point at this level, let's suppose the temperature is minus 10 degrees Celsius. So at that minus 10 degrees Celsius, will there be condensation into liquid water droplets or ice particles? Always ice particles. There will be formation of ice particles here. Formation of these ice particles. These ice particles will provide the surface on which more condensation can happen. More condensation can happen. Eventually, in this entire zone, condensation will happen. Their size becomes so very large. Multiple of these ice particles, liquid water droplets, etc., they end up making what we refer to as the clouds. Eventually, these clouds, they are not a complete solid that if a plane moves by, the plane will simply disintegrate because it has hit the cloud. No, you can pass through the clouds, you can move through the clouds. These are small tiny ice particles, keep on rubbing against each other, develop a charge with respect to each other. When these ice particles, they become slowly and steadily very large, they cannot be held in the air anymore. Gravity takes over, and these large particles, they start dropping. These large ice particles, they start dropping. As they start dropping, will they experience a rise in temperature or will they experience a fall in temperature? What do you think? Why fall? They will experience a substantial rise in temperature because the temperature near the ground surface is high. So they will experience a rise in temperature. These ice particles, they will experience a rise in temperature. That is when these ice particles, they will get converted into liquid water droplets. Frictional force will also be very prominent. They will get converted into liquid water droplets. And these droplets fall on the ground surface as raindrops. So the ice particles, they melt because of higher temperature, and that is when you have the occurrence of raindrops. But in certain parts of the country, for example, if you consider the region of Jammu Kashmir, Ladakh, parts of Himachal, Uttarakhand, Sikkim, and Arunachal, these are the areas which also receive snowfall. Remaining areas where you have observed ice falling, etc., that is not snowfall. These are the areas where you have snowfall. So why is it that snowfall occurs, or when is it that snowfall occurs? So in certain conditions, when the ground temperature is below freezing point, ground temperature is below freezing point. Now, in that case, if you have the clouds, the ice particles, they start dropping. As they fall due to the force of friction and a higher temperature, they will melt into liquid water droplets. These liquid water droplets, as they keep on falling, there eventually, because the ground temperature is so low, these droplets will refreeze. They will refreeze as tiny ice particles, snow particles. So that is why you experience snowfall. So, because of low ground temperature, raindrops refreeze to snow. That is why you experience snowfall. Okay? So that is basically why you have snowfall in certain areas. Now, by the way, before I end the class, one final point of discussion. Here we had seen the formation of dew. We had seen that, for example, in the region of Delhi, at around 8 degrees Celsius, the relative humidity has reached at 100%. Let's suppose we consider Amritsar or Jalandhar. Air is much more drier there. Let's suppose when we talk about the saturation, let's suppose saturation temperature is attained upon cooling to minus 2 degrees Celsius. In that case, if it cools down further, will there be dew formation in that case? Or will there be something else? What do you think? Good. In that case, condensation will happen, but it will not happen as liquid water droplets. It will happen as solid ice particles. The surface, you will observe a sheet of ice, very thin, transparent sheet of ice to develop, which is observed in the regions of Punjab, Himachal, etc. during the winters. That is what is known as frost. When you have the point of saturation reached below the freezing point, condensation leads to formation of frost. With that, we'll end the discussion here today. We meet again tomorrow, where we'll carry forward this discussion. We'll talk about the portions associated with thunder, lightning, and so on. So we meet again tomorrow. Twisha, why few days ago we have thunderstorms in Surat for a short? Because of low pressure conditions. These are the traveling low pressure systems which travel from the western part around the region of Mediterranean. They hit the region of the Himalayas and they keep on traveling in the northern and the northwestern part of the country. Okay, so that is basically where we'll restrict. We'll meet again tomorrow. Take care of yourself. Goodbye. Thank you.